Another major milestone in the electrification of the East Coast Mainline. British Rail's train for the 21st century has arrived. Intercity 225. The High Road North, the East Coast Mainline, one of the most fiercely competitive transport routes in Britain. 1989 has been the year of the great push north in British Rail's largest ever construction project, from London to Leeds and Edinburgh. Almost all the fixed equipment for the project along the 400-mile route is now in place. All along the northern half of the line from Doncaster, engineering work has been forging ahead to a timetable which has been carefully dovetailed into the busy everyday operations of the main line. By night, engineers have been hard at work undertaking the reconstruction of bridges and preparation of tunnels to take the electric wires. Virtually all the wiring has now been strung out, ready for stage-by-stage energisation north from York to Edinburgh during the coming year. At York, running the wires through the station had to be fitted around an already tight set of schedules for the night postal services. At Edinburgh, there have been complex works involving track, bridges and tunnels. The main Waverley Station footbridge, itself a major supporting structure for the whole station roof, needed to be raised a mere 6 inches to enable the wires to go through. Engineers decided that this method would be less costly and less disruptive than lowering the tracks. In the twin Carlton tunnels, which form the final approach into the station, there has been major reconstruction work. The 142-year-old tunnels were partly relined using specially made precast concrete sections. Over 1,000 rock bolts have been driven into the surrounding rock to give it greater strength. Finally, single tracks were relayed in each tunnel to give greater clearance for the overhead wires. A 4-month project completed on time. So too were many other projects which required the demolition and reconstruction of bridges. 39 bridges in the Scottish section were affected, many of them carrying public rights of way and busy roads, as well as essential services such as electricity, gas and water supplies. Each location required careful planning for smooth progress of the work. In some cases, temporary bridges had to be built. Because the line runs close to housing, it was invariably a case of having to take each of the bridges down stone by stone, rather than using conventional blasting techniques undertaken in open countryside. Where smaller structures, such as footbridges, were involved, it was a slick overnight job. At Drem, a few miles from Edinburgh, the old Victorian iron footbridge was too low for the wires. A new style bridge, the first of its kind in Britain, was assembled on site and lifted into place. The old bridge, a Grade B listed structure, was carefully removed for transport and later restoration at a local museum. The next morning, local residents awoke to find a completely new bridge ready for their use. It's not just passenger services that will benefit from electrification. At busy freight yards, such as this one at Miller Hill on the outskirts of Edinburgh, work is at an advanced stage, preparing huge foundations which will bear the supporting structures for the wires. With the completion of the Channel Tunnel in 1993, long-distance electric-hauled freight will have the potential to become the most cost-effective and competitive method of moving goods to and from the continent. The city of Durham and its magnificent railway viaduct, a beautiful headache for the project planners and engineers. The problem, how to complete the engineering work with the minimum of disruption and how to preserve the special nature of the journey through Durham. The answer was skill and hard work. The 135-year-old viaduct, one of the longest on the East Coast Mainline, had to be strengthened, cleaned and newly waterproofed in readiness for unobtrusive slimline masts to carry the overhead wiring. Meanwhile, at Durham Station, the northbound platform had to be moved to make the approach smoother and to raise the run-in speed to 40 miles an hour. To do this, it was decided to divert the East Coast Mainline for 9 days. Intercity reasoned that the short-term inconvenience would be outweighed by the long-term benefits of electrification. At Newcastle, the first stages of the major repairs and renovations to the station and remodelling of the track system is now well underway. A new island platform is being brought into use to help speed the flow of suburban trains through this busy mainline station. But it's the main station that presents engineers and architects with a particularly difficult task. The train shed roof, the first of its kind in Britain, was the inspiration for other great stations like York, Paddington and Bristol. It is a national monument, and work is being undertaken with care and sympathy for the surroundings. The famous diamond crossings of Newcastle have always proved something of a bottleneck in the operation of the East Coast Mainline. These will undergo major remodelling in the coming year to help speed up the arrival and departure of the electric services in 1991. But there have already been improvements in the day-to-day maintenance routines of this heavily used route. New track circuit fault detection and prevention systems are being installed so that if problems do occur, they can be put right much more quickly. A foretaste of the improvements scheduled for Newcastle can already be seen at York. A few months ago, this was the southern approach to the station, a complicated layout with slow line speeds and prone to equipment and points problems. An £18 million investment in new track and signalling is already paying dividends. Train speeds into and out of the station are now significantly faster. A completely new signalling system at York is now in operation, based exclusively on the latest fibre-optic communication systems and solid-state interlocking. A huge investment in digital science that will provide greater reliability and better quality of service. So, 5 years into the project, how is the schedule for completion looking?
We will finish absolutely on schedule. The idea is that we energise the last stretch through Northallerton to Darlington in November of 1990, and then that will enable us to do all our testing and complete the electrification works before Christmas.
With almost 400 miles of newly electrified railway to Edinburgh due to commence services in May 1991, there would appear to be an excellent opportunity to extend the route westwards to the northern end of the West Coast Mainline at Carstairs, which has been electrified since 1974.
Very recently, we were able to prove the investment case for electrifying from Edinburgh through to Carstairs, which will enable two things to happen. Firstly, a number of the East Coast Mainline trains will be able to run all the way from London through Edinburgh to Glasgow. And secondly, a number of the West Coast trains which currently go to Edinburgh but have to spend a long time at Carstairs changing engines will no longer have to do that, as they'll be able to run straight through. So that's two major improvements for two different groups of customers.
Over the past year, the first batch of 10 Class 91 locomotives has been hard at work on passenger services from London to Leeds. They've been clocking up tens of thousands of miles, a proving ground for all the new technology that's gone into them. Behind the scenes, the final design work for the new Mark IV coaches that will be the mainstay of the new East Coast fleet. The new trains, codenamed Intercity 225, are the result of 4 years' intensive work by British Rail and the GEC Group, who won the construction contracts. In all, 31 new train sets and locomotives will be built. Perhaps one of the most welcome improvements in the coaches will be the new sliding doors, which can be opened and closed by passengers at the touch of a button once the train has stopped in a station. The new coaches will be capable of running at speeds up to 140 miles an hour. Although the train is hauled by a single electric locomotive, the rear unit, or driving van trailer, also serves as the driver's cab for the return trip. The Mark IV coaches incorporate many innovative features. Each of these has been subjected to lengthy endurance trials during the past months before the trains came into passenger service. Since there have been dramatic increases in the numbers of travellers, the specifications for the new coaches have taken into account the need for wider doors to allow easier boarding and for the needs of the disabled. There are more areas for luggage. No more dodging around old-fashioned doors or grappling to open them. At stations, the passenger doors can be opened or closed on demand. The first-class coaches are equipped with 46 reclining seats, arranged in groups of 4 or pairs or singles. The Class 91 electric locomotive is both a racehorse and a workhorse. Cleaner, quieter and more reliable and powerful than the diesel engine high-speed trains, maintenance costs will be greatly reduced. Extra coaches can be hauled without incurring timekeeping penalties. With a service speed of 140 miles or 225 kilometers an hour, it can rival Europe's very high-speed trains, yet still be able to haul very heavy night sleepers over some of BR's steepest lines. And just to underline this, the 225 set a British record of 162 miles an hour during September on a test run between Grantham and Peterborough. By next May, the full intercity 225 timetable to Leeds will be in operation. Internal doors into each saloon are push-button operated and stay open as long as passengers are walking through. Again, there's plenty of overhead room for luggage. The senior conductor has remote control over all outside doors when the train is ready to depart. Most trains will be operating with 9 coaches, 6 standard, 2 first and 1 catering vehicle. This arrangement gives 20% more standard class seating capacity than a conventional intercity 125. Higher standards have been set for ride comfort and soundproofing. The interior has been designed to create a 74-seat layout that is both interesting and practical. Each train has a toilet designed for disabled travellers, and in addition, each standard class coach has 2 different types of toilet. Equipped with warm air hand dryers and paper towel dispensers, the larger of these has been designed with mothers in mind, a fold-down baby changing table. To reduce the problems of standing passengers at peak travel times, additional tip-up seats have been fitted into the vestibule walls of each coach. The interior layout of the first-class coaches has been designed to disguise the length of the vehicle. Screens divide the seating into attractive blocks, and in the middle of the vehicle, the centre aisle moves across to follow the seating arrangement. The catering vehicle provides both buffet and full dining facilities. The galleys have a full range of equipment available for the service of hot and cold meals prepared to meet the highest catering standards. Keeping in touch on the move is no longer restricted to the mobile phone owner. Every new Mark IV train is equipped with card phones in both standard and first areas. The Mark IV coaches are a far cry from the designs of nearly 40 years ago. British Rail and Intercity are convinced that these new trains are the right answer to satisfying the demands of an increasingly discriminating and competitive travel market well into the next century.